Good evening. Welcome to your Thursday evening tour around your celestial neighborhood. I'm Irene Pease, your friendly neighborhood astronomer. Back from a little vacation, took a week off. Hope you didn't mind, but I'm back and trying to mix things up. So if you've been here before, you might notice some things look a little bit different on our kind of intro page here tonight. Um, yeah, I had planned to do something relatively easy and straightforward for myself since I was coming from vacation and starting a class and things. And again, since I am teaching a class for the next few weeks, when I'm teaching whatever astronomy related class, I usually try to theme these around what we've been doing in class that week, so it can kind of supplement. And it's a little review for me and any students who feel like tuning in, always optional. Um, but also, I've been thinking about like the night skies portion and kind of separating that out, and thought I would start that out tonight. So the night skies will be a separate thing that I'll probably be posting on Sunday nights, see how that goes through the summer. And also, again, this looks a little bit different. So I'm not using stellarium, which I would normally be using to show the night skies or maybe some other things. Tonight, I'm just using open space, and I'm using a different view of open space. So it's a little bit of a tour of the universe, and it's going to be a little bit of a tour of open space for those of you who haven't used it before, to kind of see how I navigate around it. So you're going to kind of get to peek behind the curtain a little bit and actually watch me do the controls live. If you hate it, let me know. I probably won't do too many of these, but I feel like watching this kind of thing, seeing other people use open space could be helpful for me if I get around to that. But if you're interested in using open space, maybe watching someone else can be helpful for you. So we'll see. But yeah, let's jump right into our tour of the universe. So we like to do a grand tour. This is something we would do at AMNH every year, once or twice a year. It's kind of a fun thing. Um, and for me, I just wanted to poke around some different data sets, some of my favorite data sets, some that I haven't used a lot. Again, you can download OpenSpace for free at openspaceproject.com. That was up there, and I'll put it up there again. Um, Good to have a solid graphics card, but we're just using a bunch of data sets that have been loaded in from various sources, the Digital Universe Atlas that's curated at the American Museum of Natural History, as well as some other data sets from here or there. And wherever we've loaded stuff in, it's very customizable. And I do get help from some of the support team loading in different stuff every week or so. So here's some of the fun controls I have. One of the first things before we leave Earth, I kind of don't want to spend too much time in the solar system tonight, but I thought it'd be fun to go back and just kind of look at some weather systems because we've had weather brewing. So just one of the cool data sets that are in here um, is basically these images of Earth that you see. So those are date specific. So this is actually from Sunday, July 4th. This is GMT, so Greenwich Mean Time. So this doesn't match up, like I'm in Eastern Time. And this is kind of paused right now. But I think I've shown this once or twice before, but you can actually see like, oh, there was the storm brewing by the Caribbean. And if we fast forward a few days, you can actually see it kind of making landfall, climbing up the coast, storminess. Um, there's the 7th, and I think we may or may not be able to get the 8th. I don't know if, so in New York City, I'm not sure if this is some of the weather that we're starting to get smattered on us. It's kind of outskirts of that. It was a little bit stormy earlier today, and I think we're expecting a little bit more tonight. We fast forward, I think this might be in the future, GMT, so we may not have all that data, but boom, yeah, okay. there's a bunch of storminess over kind of where I am and probably where some of you may be too. Yeah, so with the wonders of open space, we can see a little bit through the clouds, but yeah, kind of neat. So that's one of the fun things that we can do with open space. But I'm just gonna kind of leave time alone for now and turn on our orbits. the hotkey and zoom out a bit. So, like I said, I don't want to spend really much time in the solar system because I've already done a little bit of that this week just in my class. And well, I've been in the solar system for the last however many decades I've been alive. Um, but yeah, I wanted to get like outside the solar system, stretch my legs, stretch my arms, get just some space. Um, so we can zip out a little bit quickly. One thing I do like to note, and I feel like they don't show up as bright. Um, yeah, they don't show up quite as bright in here. Um, but there are constellation lines. So the constellations throughout the solar system look the same. So the stars, if you can see, I feel like they're a little bit darker than usual. Um, but if you can see any red lines, I feel like they don't show up as well in the stream. Um, those are all kind of the same patterns throughout the solar system. So even as we zoom out, these are all the orbits of the planets that we're moving away from. As we zoom out further and further, we're seeing um, see a little bit of the brightening of the sun. So we move the sun out to its actual brightness compared to the background stars. And here we start to see just a little bit of, distortion. Um, Due to we're actually finally approaching some of the nearby stars. And you can see up here, so that's one of the fun controls that you can check, is how far away from Earth are we? So we're targeted on Earth still. So up here we have our distance from that target, which is almost 11 and a half parsecs, parsec being about 3.25, about 3.25 light years. So we're like 35, 36 light years away from Earth, and you can see like some of the stars that are within that distance. So these are some of the brighter stars, right? Some of the bright stars in the night sky, but there's a lot of stars that we see or that we don't see really in our Milky Way. So we have our fun object tree here. Um, One of the things we like to play with are the brown dwarfs. Ooh, look at that, brown dwarfs. So we have a whole data set of brown dwarfs. Actually, in New York City in particular, there's a huge brown dwarf research group, BDNYC. So a lot of people who study these small, faint objects. And if you want to hear more about that, there's a podcast, AAA Sky, AAASKY.NYC. I interviewed Dr. Emily Rice about these objects because she's one of the people who studies these. So kind of neat that there's all these other kind of star-like objects. They're not quite stars. They're like quasi-stars or really successful planets or however you want to think about them. But based on the way they formed, they're not really classified as stars. So it turns out that we're thinking about, this is what I learned from my podcast with Dr. Rice, was that we don't necessarily classify these based on their mass or their size, but maybe more on how they formed is a little bit more of an important concept for these brown dwarfs. So things that are kind of somewhere between a Jupiter-like object and a very, very small star-like object. And there's an awful lot of them, which is great, but they're really hard to find, which is a fun challenge. I don't want to say not great, but it's a fun challenge. So here they're kind of color-coded and brighter so that we can see them. And then just to get kind of a sense, again, of where we are and how far we are, we have some grids in here. I think, yeah, the radiosphere, this nice bright grid. So this is a grid that's about, I want to say it's about 70 light years away. We come in, does that match what the parsecs say? Yeah, give or take. Yeah. So about 70-ish light years, um, 70, 80 light years in diameter. So this should be the extent of our radio signals. So considering we started sending radio signals out into space back in the late 40s, early 40s, late 30s, they would be out to the edge of the sphere. So it's constantly expanding. washing over all these other objects in theory. But really, when it gets out that far, it's so ridiculously faint, it would be like unidentifiable anyway. We do see this little cluster over here. I believe this is the Hyades cluster in here. Nice little open cluster of stars there. But one of the other fun things to look at out here is that's in the solar system are the exoplanets, because everybody likes exoplanets, right? So this is a data set of exoplanets. So all these circles aren't individual exoplanets, but those circles are markers of star systems that contain one or more exoplanets. So each circle could represent more than one exoplanet if we've seen more than one exoplanet in that star system. So it's kind of cool to see like how many are, if you want to say, kind of in the solar neighborhood here within 70, 80 light years. There's a lot, and we just keep finding more and more and more. If you want to look at a more extensive data set, I don't think it's part of this one. Maybe. Oh, yep. No, there it is. You can kind of see this beam extending out, out kind of towards the top of the view here. So those are from the Kepler survey. So if we come in here, this is basically like one little footprint on the sky, where we had this one survey that just stared at one part of the sky for a really long time, like a couple of years, and just found a whole mess of exoplanets there. So there you can see the footprint of that telescope, the Kepler telescope, that was aimed at this patch of sky near the constellation Cygnus the Swan. Just for kicks, I turn on the constellation figures for reference. Oh, just kidding. We're way too far out. Okay. Now we have the constellation figures for reference. So kind of off of the wing, it's the eastern west. Just kidding. Western wing of Cygnus the Swan there. This beautiful swan, in case you weren't sure. But yeah, just staring at this one patch of sky and finding just a whole mess of exoplanets. So presumably there's nothing really special about that one direction. It is in the plane of the galaxy, but beyond that, there's no reason to think that if we looked at any other direction that's in the plane of the Milky Way galaxy, we wouldn't see like a similar density of exoplanets. So let me go ahead and turn some of those off, our exoplanets. Exoplanets, that's all good. And we can come out a little bit further to kind of see the shape of our galaxy. And just a quick tour of some of the deep sky objects that we see. So when we talk about deep sky objects, when I'm talking about those either in an astronomy lesson or in the like when we're talking about what to see up in the sky and stuff, we're mostly talking about clusters and nebulae and other galaxies. So two types of clusters. We have the globular clusters, which are the yellow dots, and then we have open clusters, which are, I think, green. Yeah, I think they're green. But those, I think, are a bit closer. So let me see if I can make those a little bit more visible in here. So if I turn the opacity, crank them up a bit. Oh yeah, there's some green dots in closer to us. So hide that a little bit. So the green dots, you can see we've cataloged a bunch of them in here, pretty close to us. Those are mostly in the plane of the Milky Way galaxy. So as we're looking for those, we're kind of looking through other stuff, other gas and dust and whatnot that's in the plane. So there's other stuff obscuring our view. So most of those that we've cataloged are pretty close to us. These yellow spots, those are the globular clusters. Those are more massive, more populated, a bit denser, higher stellar densities. And those are in what we consider to be the halo of our galaxy. So not necessarily just distributed within the plane, like within the spiral arms, but off the plane, either north or south of the galactic plane. So those we can see a bit further away. One, they have like a higher, I guess you could say, surface brightness, um, and also we don't have to look through like all the dust and gas and stuff to see them. So those are our globular clusters, and we'll see pretty pictures of those at various points. I didn't bring a lot of pretty pictures tonight, just kind of reviewing a lot of the stuff that's in our galaxy and beyond. So those are our star clusters. And then we have different nebulae. So a nebula, again, is just a huge cloud of gas. And by huge, I mean tens or hundreds of light years across. So we have the star-forming regions, which you'll see are, oops, a little bit fast there, are mostly in the plane of the galaxy. That's where a lot of the stars are forming. And then we have the remnants from old dead stars, planetary nebulae. Those are also mostly in the plane of the galaxy. And supernova remnants, also mostly in the plane of the galaxy, right? So most of the starry stuff is in the plane of the galaxy, star forming, star stellar evolution. But then there's some stuff like the globular clusters and a lot of dark matter and some other things that are up above or down below, I guess, north or south of the plane of the galaxy. So that's kind of where that stuff is in the galaxy. Of course, in the center of the galaxy, there's a supermassive black hole. That's really fun. We can kind of center on that. So we can whirl and swirl around there. And there's another fun thing that I found in here. I'll turn off a couple of these data sets so you don't need all these little spots and things. Goodbye, planetary nebula, leftovers from small stars, supernova remnants, leftovers from really massive stars. And I just saw this data set in here today, and I thought it was pretty exciting. So I said, hey, why not? I wish I'd had this. I wish I knew this was here a couple months ago when I was talking about this stuff. Oh, look, it's the labels of the spiral arms. So let's turn us over so we can read those. So that's kind of neat. We have a nice little map of the galaxy. A little friction here. So we're kind of on the, let's say, the part of the Orion spur, almost a gap between the Orion spur and the Perseus arm. But yeah, that's us. So with the constellation lines on, we can still see a marker of where we are. So there's the outer arm, that's towards the outside, which winds around here. The Perseus arm and the Orion spur, which I think basically spurs off of the Perseus arm a little bit. Sagittarius Carina arm, Scutum Centaurus arm, and Norma. So basically looking in this kind of direction, these are kind of southern constellations. So some of those names like Scutum, Norma, Carina might not sound as familiar as some of the names in this other direction. Outer is not a constellation, but Perseus and Orion are constellations. Sagittarius is kind of a southern constellation. It's visible from most of the northern hemisphere. It's part of the ecliptic, but it is south of the celestial equator. Carina, Scutum, and Norma are farther south of the celestial equator, and actually Scutum's not. Just kidding. Centaurus, Norma, and Carina are a bit further south of the celestial equator, and mainly considered like southern constellations that we wouldn't be able to see from New York or similar latitudes. So yeah, so those are the arms that are nicely labeled for us in open space, which is kind of handy stuff. So I can turn those off and come back to, let's see, we don't need the arms anymore, but I do want to look at our local group. So these little dots, so I can stop a little bit of that motion, kind of pan around this way. So the green dots now are other galaxies. And some of these might have labels. I think I need to turn on the labels for those. I believe these down here, these are the large and small Magellanic Clouds, the LMC, SMC, that again are visible from the southern hemisphere, not so much visible. Why am I not seeing labels? Local group labels. See if that worked. Not so much from the northern hemisphere, but more southern hemisphere. I don't know. I'm not seeing labels. That's okay. But yeah, all these green things. Oh, there's some labels. All these green bits. Oh, those are groups. Just kidding. Local group. Labels. I have a labels option in here. I know they have labels somewhere. Yep, there they are. Found them. Okay, that's better. So I can tab that out. So yeah, so LMC, SMC, and their smudges are a little bit displaced, but can work on that. So the green dots are part of our kind of collection, the smaller galaxies that are kind of more gravitationally bound to the Milky Way, as opposed to those that are bound to Andromeda. Let's turn these off for now. So if we move out a little bit further, now we can see some blue dots that are also part of kind of our local group. There's some yellow, there's the blue. So the blue dots are all kind of gravitationally bound. They're kind of up towards the top here. I'll bring them around front and center-ish. Those are all kind of more gravitationally bound to Andromeda. So the Andromeda Triangulum complex over here. So Andromeda being our largest spiral neighbor in space, and Triangulum being another nearby buddy. If you see Triangulum somewhere over here, should be roundabouts over here. So yeah, there we go. Triangulum is up here. So those three galaxies are the main galaxies. Andromeda, Triangulum, and Milky Way are the main galaxies of the local group. And then there's a couple other smatterings, some of the yellow here. So a lot of dwarf galaxies, for people who study dwarf galaxies, plenty of those around for them to poke at, prod at, explore. And then that's just like kind of on the outskirts of the main. Whoosh, turn these on. Uh-oh. The main cluster of galaxies that we're part of, which is the Virgo cluster. And those should be in the Tully data set, which is not happening at the moment. It almost looks like we're a little bit frozen, and I might need to restart. Fortunately, I have a button for that. Yeah. All right. So I'm just going to quit out of open space if I can. If it'll let me. It's being a little bit grumpy here. That's weird because normally the Tully set is not an issue at all. Oh, wow. And now everything's freezing. Yeah, Tully's really, really grumpy tonight. Okay. So this is awkward. Well, I think this is still streaming. But even OBS is a little bit frozen. So not sure what's going on there. Or even if this is still streaming. But everything is really, really frozen and not responding. Like nothing is responding. That's fascinating. Okay, so not panicking, but I'm going to try to see if I can't leave and come back. Because I wanted to explore more of the universe tonight. And right now that doesn't seem to be happening. So we're going to We're gonna do a hard end and maybe come back, if anyone's still around. Okay. Wow. Uh, all right. So, if people are still on, you're pretty awesome. Um, my whole computer just shut down. OBS stopped working. I don't know. Everything's frozen, and now my Mac won't start. So that's the end of the tour for tonight. But I'm gonna say to be continued, and we'll get to the rest of the universe another time when I figure out how to get my computer running again. Yay! So that's what I'm doing tonight. Clear skies, everyone. Be safe out there. If you haven't yet, go get vaccinated.